Alright, okay, so I'll discuss what is all about this non-uniform load in ETABS. Alright, we have a water tank here. So I'm just only drawing a single plane of that water tank. This is the side plate of the water tank, okay? Maybe I'll try to draw this in an isometric. Looks like this. So the height is maybe 3 meter. The height of the water tank is 3 meter, and I'm denoting this as A, and this one as B. All right. Next thing is, well, let's see the pressure. Pressure at A is the gamma H. The pressure is always gamma H. Gamma is 10 kilonewton per meter cube for water, and height is like this 3 meter, so this can be 30 kilonewton per meter square. So pressure at A is 30 kilonewton per meter square, and the pressure at can be B is 0. So this is the pressure. So now if you open ETABS, so you can see that if you adding a new property of M30 and shell tint to wall having a thickness of 200. Okay, you're picking up a wall having W2 as a property and placing up right here. Alright. Oh, well, we don't have a column here, but actually, I'm not providing any beam or column anywhere. Uh, it's resting on the slab. Maybe let's provide a beam here for simplicity. B is right there. Okay, beam is also there. Alright, now let's come back to the problem. In the shell load, if you have a non-uniform section, the pressure, the point, the load at any point xyz is denoted as a function of ax plus by plus ez plus d, that is 0. Okay, what and all are these numbers? Okay, the pressure is a function of ax plus by plus cz plus d. Okay, so what in all of these? These the actual value. If you want to convert this non-uniform into uniform, you can give the coefficient A, B, and C as 0. So this pressure will act as a uniform distributed load in the case of slab. Okay, this is the actual kilonewton per meter square. Okay, now let's see what is A. A is the pressure variation, delta pressure in direction X. B is a change of direction, change in pressure in direction Y. C is delta P, change in pressure in local Z, okay? Or global Z, I think. Will that need to be confirmed? This can be, okay, this can be based on local axis, okay? Yeah, local axis confirmed. Yeah, local axis confirmed. Okay, in the above case, I don't see that there is no force variation in all the x and y direction. Okay, the force is varying only in z direction, as you can see from here. Okay, in x there is no structure. Okay, in this there is no structure. So in y, all these, if you consider a horizontal section, all the point forces remains the same. And also in Z, the actual pressure is varying in top, that is 0, and in bottom, that is the maximum one. Okay, so let's calculate what is the force provided by this. Okay, from this we can take we can pick up the values from here. Well, so pressure equal to 0, so I'm considering at A and at B. And what's at A? At A, pressure is not 0. I'm gonna take an eraser. The pressure is at A. The pressure is 30. So A and B are 0. So we can have C, Z plus D. Where the Z is 0. Z is not. Z is well 3 meter. Z is 0 because you're measuring everything from this base, okay? Now at B pressure is 0 and what CZ plus D where Z is well 3 meter. Okay, so let's solve this equation. From this pressure is 0, so 3 3C plus D is 0. This is equation 1, and in equation 2 pressure is 30 where Z is 0. So the first equation will become 0, D equal to 30. So we substitute that D equal to 30 in this first equation. You'll get substitute D equal to 30 in here. Substitute, you'll get, well, 3C minus 30. Sorry, 3C plus 3C equal to negative 30. 3C equal to negative 30, where C is negative 10. So this is the first value we got, and D is, what is D? D is 30. Okay, D is 30 and C is negative 10. So simply apply this. What? C is negative 10. C is well negative 10. Sorry, negative 10. Oh, what about D? D is 30. D is 30 and C is negative 10. Select the shell and hit apply. If you ever try to run an analysis on this, well, I don't want to see the model's forces, okay? I don't want to make this model run because I hate this earthquake and run it now. Give him a rough name. Well, that's if you ever played an animation, you can see that's been jiggling. No changes. Alright, if there's no changes, let me mesh that slab. Before analyzing, I need to mesh that slab. Come on, coming to assign, we can have shell. Well, auto wall mesh options. This has not been meshed. Auto rectangular mesh. Okay, now if you trying to run the analysis, well, not. What will be that? Let me simply try to shell stresses, and this is shell stresses and S maximum on the maximum faces. Okay, so you can see the pressure variation uh, approximately 0 and coming back to maximum right at this faces. Okay, so minimum top, maximum at bottom. That's the basic thing. Okay, the pressure is very small. I don't see why this is so small. So that's all about that.